We're going to talk about chi-square distribution. And while this looks like an X, it's really the chi, which is in the Greek alphabet, and then the 2 for the squared. So let's talk about facts about the chi-square distribution. Most of what we're going to talk about in this course talks about quantitative data, which is counts and measurements like height and age. But now we're going to shift and we're going to talk about qualitative data. And remember, that's data that has names and categories like eye color and ranking. Qualitative data is important since oftentimes your data is in categories. A lot of times in education, we look at grade levels, we look at stuff based on certain tests like science, math, and language arts. So it's important that we at least cover one of the qualitative tests. So since you're using qualitative data, you can't use the student t or the normal distribution. You have to use something called the chi-squared distribution, which is a right-skewed distribution, and it's written as a chi-squared. And you see there the x looks a little bit different, and that's the actual chi. So there's 3 different chi-squared tests in our book. We're only going to focus on chi-squared goodness of fit. It's kind of the easiest to understand. So there's rules for chi-squared distribution. The first rule is that the curve is non-symmetric and is skewed to the right. The second is that there's a different chi-square curve for each degrees of freedom. Now, degrees of freedom for us for this one is number of categories minus 1. And that's going to look a little bit different than what we did in the one mean t-test. So remember, with chi-squared, chi starts with C, so think of this in categories. So degrees of freedom is number of categories minus 1. So the third rule is the test statistic for any test is always greater than or equal to 0. And number 4 is when the degrees of freedom is greater than 90, the chi-square distribution starts approximating the normal distribution. The mean is located just to the right of the peak. You don't have to memorize these rules, but sometimes it's helpful to know what they are. So, in the goodness of fit test, in this type of hypothesis test, you're going to determine whether the data fits a particular distribution or not. And we're going to do the next video on this.